In this video, we are going to talk about oxymercuration demercuration. For example, let's assume that we have one propane and then we add mercuric acetate in the presence of water, and then we make a reduction using sodium borohydride. What are we going to form? What we are going to form is an alcohol. Now, there is a possibility of forming a secondary alcohol and a primary alcohol. However, this reaction follows the Markovnikov's rule, and therefore it is going to form the secondary alcohol. So let's go through the mechanism and see how this reaction occurs. How does this reaction happen? In solution, the mercuric acetate will ionize, and when it ionizes, it will give us mercury acetate ion. And also the acetate anion. Now, we can see that this is an electrophilic center. So therefore, what happens is that because the propene has lone pairs of electrons, it then donates its lone pair of electron to this electrophilic center. So there is this donation. When it happens, it leads us to form this product, intermediate actually, which is the mercury acetate being at the side with this carbocation form on a secondary carbon. Or another possibility is the mercury acetate can be substituted on this side, and then we will form a primary carbocation on this primary carbon. Now, we see that this reaction will favor this intermediate, and the reason is because this is a secondary carbocation and this is a primary carbocation. The secondary carbocation is more stable than a primary carbocation because the methyl groups that are attached to the secondary carbocation donate electrons into this electrophilic center through inductive effect, thereby making this carbocation more stable than this primary carbocation. And therefore, the reaction will favor this Markovnikov's addition. So it will proceed from this intermediate. From here, this mercury has lone pairs of electrons on it. So what will happen is that this intermediate is in resonance with this other intermediate, which is it will donate its electrons to this electrophilic center to form the cyclic mercuric acetate. And therefore, the positives moves to the mercury. So what will happen is that in the next step, water has lone pairs of electrons. Now, this reaction takes place in the presence of water. And because it has lone pairs of electrons, it can use one of its lone pairs to attack the secondary carbon here, thereby releasing these electrons back to the mercury. So we are going to form this intermediate as well. With the water molecule here, but this water will bear the positive formal charge. So the next step is that, remember that when we did this, there is acetate ion in solution. So this acetate ion will use one of its lone pairs to pick a proton, thereby releasing the electrons back to the oxygen. and that will lead us into forming this intermediate. So in the final step, what will happen is that we will use the sodium borohydride. The hydride from the sodium borohydride is going to reduce this part, which is the mercury acetate, and then to give us our final product. So we are going to use sodium borohydride in this step, and that would remove the mercury acetate part to give us our final product, which is this product. So this is how oxymercuration demercuration occurs. Now let's solve the following examples. We have this molecule, and then we put in mercury acetate in water, followed by a reduction with sodium borohydride. So this is mercuration demercuration reaction. And since it follows Markovnikov's rule, at the end of the day, we are going to form a secondary alcohol. So this is what we are going to form. So this is the major product of this reaction. And then so we have a proton here. This is a proton. Now, what about this product? So this product is also mercuration demercuration. So the OH will be substituted to the carbon that is highly substituted. So in this case, we are going to form this product, because you can see that this is a tertiary carbon and this is a secondary carbon. So the OH will go on to the tertiary carbon and the proton will go on to the secondary carbon. Now we can see that for this one, it is propane. When you do mercuration demercuration reactions on alkynes, you also form alcohols, which also follows the same radioselectivity. So let's show this. So this is what we are going to form, because you can see that this is a secondary carbon and this is a primary carbon. So the OH will be on the secondary carbon. However, anytime you have an alkenol, this is an alkenol, what will happen is that there is a possibility of tautomerization. So this alkenol will tautomerize to give us the final product. So what will happen is that this lone pairs will pick up this proton, pushing these electrons to this carbonyl center, and therefore we are going to form a ketone. So this is the final product for that reaction.